Welcome back to Made Up of Wires, where we're decompiling a very battered field notes. Sat in my back pocket for a long time. Or maybe we'll go back to Symphony of the Night. How about that? We've been decompiling Symphony of the Night for over a year on this channel. I appreciate everybody who has stopped by, commented, helped. Really appreciate it. Helped me with my technical errors, my window management. Hey Gabe, good to have you back. Hey, dig down deep. It actually isn't the anniversary. The anniversary was about a month ago. I just forgot. I think there's been, it's been over 200 videos so far. Many hours. So that's probably about, 400 hours or so of decompiling. And still don't know what I'm doing. I think really appreciate everybody who watches. And if you do watch and you haven't subscribed and told your enemies yet, please go do that. So what are we working on today? Richter. I need a Richter GIF, I think, to put over my head. That'd be nice. So we were looking at Richter. I always talk about the software aspects and other things like that of the project as well. We have to always consider those things. How can we make it easier for ourselves? How can we make it easier for others? And I've been working on that a little bit this morning. So we'll get to Richter, but I'll talk about some of that stuff as well. So we decompile right now primarily 3 versions of the game. The PlayStation version, which is what I'm focused on mostly. The HD version, which is the JP 1.0 version, but it happens to be on the every version of the PSP disc and every version that's been released since the PSP. The only major differences between HD, if we look at Soten.fun, we can actually see that. The only major differences, are in DRA. Otherwise, HD and JP 1.0 are mostly the same. The test levels and things like that are a little different, but it's mostly the same. This seemed to be basically like a test version of the game as they were developing the PSP version of the game. It looks like Familiars might be different. That might be worth looking at some point. And then, of course, the PSP EU version of the game. The EU version, because that was the first version with multi-language support, and that's actually the version that's on the Requiem collection and everything else. Yeah, what is a version? And so Gabe points out that it is a version of differences. I talked about that a couple weeks ago, and I did a small prototype, but I have to find a feature that I like that's big enough to make a difference, but small enough that it's tractable. I did look at adding feature support, and so you could turn things on or off instead of them being bound to a version of the game, and then a version of the game would be a collection of those feature flags that are turned on or set one way or the other. And I haven't got around to finishing off that prototype, but I will in a bit. Anyway, we have lots of different versions of the game. When we build the game, usually the default version is the US version of the game, and we have the most overlays here, and so we see the most stuff come up. But we can build the version of the PSP EU version, for example, and we just have to specify the version. That's interesting. Not sure what caused that. Let's clean and see if we still get that. Uh-oh. Oh, drat. I might have hurt myself. I was working on some things in MWCC Gap. I don't remember updating that though. This was just working not that long ago. Yeah, I have no idea what just happened there. Anyway, when we build things like that, we'll get errors like this. So early on in the build process, part of it that worked with the PSP version was extracting assets. And some of the things that come from the PSP differ. So sounds, images, they differ from the version that's on the US version, and those differ from the JP 1.0 version as well. And so when we build for one version of the game versus the other, we always have to clean and then build again to resolve that. So I was working on getting that to not be an issue. That's not what I wanted. Where is my... Oh, that's why. I rebased. Where's this other branch that I had? Too many branches, not enough time. Not build undefined. This is another branch that I was working on as well. I'll go over that quickly. This is again, this is oh, I accidentally committed to this branch. That's why. Okay, so we have things like sound effects and basically just name spacing these to when they are unique, to go into directories and be named things that are specific to that version of the game. And then the other thing that I was working on is this, which is, we'll see where this goes. We have a get ignore rule, and we ignore all these things in the config directory, but the config directory is very important. And a lot of our tooling doesn't treat it as important. I find the splat config, like when you are deep into splitting files and offsets and all these numbers are spinning around in your head, and then you run a tool and it does a git clean on the config directory and blows all those changes away. I find that infuriating, and that's happened to me a couple times. So one of the reasons we do that is because we write a bunch of stuff to that directory, so these undefined functions are there. That's something that Splat generates when it finds a function, but you haven't provided a symbol for it. It's going to throw it in this undefined, one of these two undefined symbol files. And so just moving those into the build directory, I mean, it's not overly complicated, but we have lots and lots and lots and lots and lots and lots of these files. So it meant going through and fixing all those, but then also fixing our config builder to put that new path in there as well. Hey, Desic, Guest 73, good to have you back, as always. So let's get back into Richter. We did some good work yesterday, and I think everything got finished that we were working on. So let's go back to the entity Richter function, and see what else there is in there. We may want to just get going on the big one. So we want EO6. Oh, grep. Oh, I can Unix sometimes. All right, so we want entity Richter, and I'm probably in the, oh no, I'm in the right directory. I think we're gonna go for this bigger function, which I think is this one. Many jump tables. So we have at least 3 really big switches. But not a ton of code. This will be nice to get done if we can do it. I don't know if it'll be done in one day or many days, but we'll see. Need to find a tab worth looking at. So if you haven't watched a decompilation before or don't know what's going on, I'm taking the assembly that we've extracted from the disk. We extract the assembly from the disk by finding each of the files on the disk that get loaded directly into memory by the game. And then we split them up into different segments based on some heuristics that we use based on how compilers work and how they break up data and functions and other things like that. And we find the functions and take the machine code, convert it into assembly, and then we take that assembly and we want to convert that back into C code. And when we're done, we want our C code to compile to exactly the same thing that was on the disk. We have a ton of functions. And fortunately, we probably don't need any of those declarations. We're probably going to have probably some of these addresses are within the grick entity. So I'll probably have to spend some time working on those offsets. Just a few globals that are unknown. So to get started, I'm going to get rid of all of the function declarations. We have some saved reg 3. This error is related to this var s3. What we'll see is that there are possibly cases, probably in the generated, I would say in the generated code, not necessarily the C code, where this register might not be set. And so M2C can't figure out whether or not a code path would always set this register. And so it puts these lines here. Often the way that the C is written, it would be impossible not to hit a condition. Sometimes it's true though, and it could be uninitialized. There are cases like that. But for the most part, we can ignore these. That's what it's telling us, and I think M2C is trying to be helpful there, but it's not super helpful. We have an odd offset on an entity, which we'll get to that and see what that looks like. We have another saved reg s3 somewhere? We do. We're just going to turn that into a or equals. That'll be fine. Some missing declarations. Did I delete too much at the beginning? Oh no, we just don't have those yet. Let's figure out where the grick player starts. And from there, we'll be able to tell which of these are in that structure. And then I think it's early enough that I'd rather add all of the symbols and then re-export this. So I like to line this up, and I'm going to grab a calculator. The GRIC struct is 3DO in size. So to find the end of that, I just add 3DO to that address. And I always put the K on there. Sorry, Richter. I know you don't like it when people do that. So too many X's there. So basically I want to see where are we ending, and we're ending right here. So we have two variables down here that are not part of this structure. What about above? All of these are not. So the ones that we don't know about yet, they're not part of GRIC. So let's, I'm going to map the GRIC ones first. Because if I add those as symbols, then I can re-export. I don't want to do too much work before I do that. There's no sense in cleaning things up, only to have to do them again. All right, so GRIC ends at 98. 98 is not part of GRIC. This is a player status. This says player status is size 334. Is it possible that there's been things that have been removed from player status? I just want to see if this has changed lately. Yeah, I think that comment is wrong. I think player status is 3DO. At least that's how I've always treated it. All right, so coming back here, there's a couple ways to do this. I think I'm going to go the long way, which is calculating these offsets. And it would actually be nice. I'm going to cheat, and I'm going to get a I'm going to use a spreadsheet actually. Usually I would do these one by one, but there's a lot of them, and I don't want to do that. So let me load up a spreadsheet. We could do this in like Google Sheets. A spread cheat. That's right. I'm going to cheat with my spreadsheet. Is it opening? I find it amazing. So, I mean, my computer isn't the fastest computer ever, but it is relatively recent, and it could take like 30 seconds for a program to start. What's up with that? Okay, so that hopefully split into exactly what I wanted. And now I need to split. Now I have to remember, I don't use Excel frequently, believe it or not. I used to use it more, but not anymore. Let's take a text split. I'm going to split on an underscore. Oh, I thought this would be more straightforward than it is, but might as well just use awk at this point. Oh, there we go. One second. Sorry, doing all this off screen. I'm just going to do that. We're going to do that in awk. So what I want is, I just want the numeric portion. So I'm going to run that through sed. And, well, I don't need to do that part instead. I'm going to take... Oh, where's my vertical? There we go. All right, so my last column is the address. I need to take that and subtract. What? Where's my starting point? Here. And that is going to be in decimal. I need to convert it back. Oh, and of course percents are funny in Vim. Percent is a placeholder for the file. I always forget how to escape that. Put a new line in there. What am I doing here? Why is my subtraction not working? Make sure I have 5 correct. Make sure that's the correct field. Is hex or is awk not going to convert these for me automatically? So there's a sternum. Let's try that. No. sometimes the GNU versions, oh, they don't have a, so that should be, it should be there. What is going on? Well, now I have these exported already. Now I'll go back to my spreadsheet. Sometimes I just flip between a bunch of different tools until I get the text processing that I want. So let's see. Go back here. Apologies while I don't share my spreadsheet, which is more embarrassing than the rest of the stuff that I'm doing. We'll get there though. I'm going to do one more thing, and then I'll bring this over. I need to go back over here and grab the offset for player status, which starts here. My formula contains a syntax error. Nice. Okay. So I'm using base to num, and then num to base, and kind of going back and forth between hex and decimal, and then doing the string concatenation there as well, and that works great. And let's see if I can do a columnar paste. How am I going to do this? Let's do it this way. Paste this in. And then grab this. I like using TextMate on the Mac as my, when I want a fancy text editor. And its column editing is, I haven't found anything much better than it. And unfortunately, nothing else really works like it. So what do I have here besides a missing 0 at the front? Not terribly important, except for, there we go. Except for style. So the first column is obviously the address that this is at. The second column is the offset from this GRIC starting point, and then the third column is the equivalent address in the player, G player. And so each of these other addresses I should be able to, except they don't have the OX, of course, prefix. So why would anything ever be easy? I should be able to look each one of these up. And find them. And of course they're all falling off the end, because why wouldn't they? Where did I go wrong? Familiar stats shouldn't make a difference here. I wonder if I didn't convert bases correctly. That doesn't make sense. So I know that this last address, this does look like it aligns to exactly where I thought it would, which is 10 before the end. So my math there works out. Did I not have the right starting point? Maybe I didn't start correctly. Let's try it again. No, I started correctly. So, what is going on here? Is there... No? It's possible that this number in my spreadsheet is getting calculated wrong. Let me just do a sanity check in my spreadsheet. And I'm going to start with the GRIC offset. I know you can't see this, but it's mostly for me. Uh, 801 D1 5EO. Yeah, those look the same. So it looks like my math is right. Let me just double check it on a calculator again. I was hoping this would be a faster way to do this, but at this point, it probably, I could have done this manually. No, my math is wrong. Yes, it is wrong, and I can... No. I'm adding the wrong things. Let me try one more thing, and then I will never do this again. I know why. I was looking at the wrong struct. I'm supposed to be looking at player state, not player status. And that makes much more sense. And was my... Didn't start with the right offset then. So, we'll do this one more time. What's the O when I do that? Oh, there we go. There we go. Better, hopefully. My hope here is that I will be able to find all the GRIC offsets, and we'll see if that comes to pass. But now hopefully we have better offsets. Yes. I don't have pad. Oh, I don't have pad pressed yet. So the way that I want to write these is so that I can copy them into the symbol table later. So I'm going to write them like this, and then I can edit them later. So this is the format that the symbol table is expecting, minus the semicolon, but I'll add those later. And so I'm just going to go through each of these addresses. And I should do this. Not with a K again. I think it's not Rick with a K. I think Richter ever went by Rick. I guess Castlevania Netflix show may have addressed that at some point. I haven't looked at what the logic is for debouncing buttons and putting them in pad held. It might be interesting to look at one day. Timers is a tricky one. So timers, this is going to be the first index of timers. So we'll call that timer 0. There will be a bunch of these, and they're all 16 bits. So this next address, for example, won't show up here. So I just have to do that math myself. So that'll be timers 4. The next one will be 16 plus, so 8, 9, timers 9. And then timers 10. And that's going to go through, it would go through 1E, but we don't have 1E, so 624 timers 12. Timers 13 and timers 14. there was actually kind of a fun, not fun is not the right word. There was an incident yesterday where a new version of Splat and Spim were released. Among other things, they changed how assembly is emitted, and it's kind of a nice change. So they put a non-matching symbol for non-matching things. They get rid of the size, the way size is calculated. Instead of being calculated at compile time, it's calculated when the assembly is emitted, which means you can't manipulate the assembly as easily. But that's a pretty rare thing to do. But because of that, and because of a bunch of the infrastructure that expects the assembly to be emitted in a particular way and certain macros to be defined, it broke us, and it broke several other games that didn't have a version pinned. We actually had our Splat version pinned fine, and so Splat wasn't affected, but Spim was just relying on the transitive dependency, and it picked up the later version of Spim as well. Okay, so we got all these, and we have a nice big table here. Now I'm going to take this back, and I'll manipulate this in Vim, and actually I could just do it in the symbol table. Look at that mess. Get all that cleaned up. Just making sure that this is the way that I expect it to be. Yeah, so something like this, I want to be able to select the word on each line individually, and TextMate allows you to do that. Because now I have all these extra pieces of cruft, and so it would each line then would get its own caret separately from the others, which is pretty cool. Almost there. Oh, why didn't you work? There we go. So we have all those symbols. Yay. So now I'm going to export all of that again, and we're going to go through here. And there's nothing really of value. So I'm going to delete this. And we're going to start a new one. And there's nothing there. This is already reloaded with the updated symbols. Make sure that it is. And let's do it again. So we'll get something very similar. All those will still be listed. They'll just have names now. And there may be some of these other ones that are in the entity table. That's probably worth looking at as well. But now I'm going to get rid of all of that. We still have these to worry about. Actually, these will not be in the entity table. 8018 is the start of the stage overlay address space. So I know that these are all stage variables. And the entity table's part of, I think, main's address space. So let's find these others and see if we can tell what they are. I don't have the data really split by file yet. This looks like an array of 32-bit values. I'm going to assume that they're signed, then we'll change it if we need to. That was the second block here. The next one we're looking at is 250. This looks like, my guess is it's pallets. And so we need to treat these as a flag followed by a number. I don't know that for sure, but that's my guess. And so I'm going to treat these as unsigned 16s. And we could go down and see where it's being used. Sometimes that'll, pallet. Sometimes that'll help us. These look like pallets as well. We don't have a type def specifically for pallets. So these are being treated by SPIM as 32-bit values, but I think that they are 16-bit values. And the FFF0 is what's hinting to me that that's the case. And the fact that kind of these bytes all align. So we have, in this top nibble, they're all 1. This would be all zeros except for the 5,000, which I think is reasonable as well. So I'm going to treat it, it's either one of two things. It's, no, it's not pairs. I was going to say maybe it's pairs of 16-bit values, but I'm pretty sure it's just 16-bit values. And the last set of zeros there is padding that the compiler emits. So I'm going to say here as well that these are unsigned 16s. Let's do signed 16. And then if we have to fix it, we will. I think the same thing here. Actually, these might be 32-bit values. No, they're signed. Sorry, not. We don't know if they're signed. It's possible that they're pairs. Again, whether they're signed or unsigned, not clear. These also look like signed 16s. Often the FFFF is used as a terminator. Hey, Kaznor. Good to have you back. Oh, timer 14 is a typo. Sorry, Dizik, I wasn't watching your comments. I will go back and fix that. Appreciate it. We will fix that. So these, when they're struct fields like this, it's actually not, these symbols are only there for us to get a nice assembly output, and they don't really have any other purpose. So they're going to go away anyway, so I'm not too concerned about them. But then we have to go back through and do the same save register stuff. Some error up here. I probably typed Vim commands into a text editor, which is something I frequently do. Oh, because I fixed the spelling up there and then I didn't fix it down below. Uh, 171, we have a label. So M2C doesn't really keep track of where different switch labels go. And so often it'll do something like this where it puts the switch label in the wrong position. I don't think we need this. Basically, this is a big loop, and this is just going to the next iteration of the loop. So I'm hopeful that not keeping track of that won't hurt me, but we'll see. Okay, so we have some incomplete types. Oh, where is that? 189? We can do one of two things. Oh, we know what the type is here. 210. This actually is a good hint as to what the type is of the array as well. When we have some variable multiplied by a constant, that tells us that the stride, or the width of each element in the array, is 4 bytes, or typically that's what it does. And so if we go back up here, we see that we have a sine 32, which is also 4 bytes. So that's a pretty good indication that we at least have the size of that correct. But for whatever reason, GCC didn't like the dereference dance that M2C produced. Let's see, 2 more of those, 364. Hopefully it's the same variable. And if it's not, that's okay. And so these are the same. So stride at 2, stride at 2. And we know what the types are, so that should be fine. We can just get rid of that stride because of pointer arithmetic. And 79% is not too bad. We got something compiling, which is always good. So I want to go through first and see if there's anything like super obvious missing stuff or anything like that. It looks like player draw might be something up with that. We're going to get a bunch of the same symbol references that are incorrect. And this looks... Oh, this is because we need to fix the struct access. That's probably the next thing we should do. So let's do that. Let's save. And then all of these, anything grick underscore is going to be replaced with grick. Actually, let's do the timers first. The timers are going to be g underscore rick dot timers. And then I'm going to use a regular expression to deal with that. No, what is my... Do I have matches here? Yeah, there we go. Oh, awesome, Powell. Game Boy Advance. I'm trying to think. Game Boy Advance is playable on DS, right? I think that's true. I don't know what the interface is. I have a Evercade EXP, and it's up on my shelf up here somewhere. It's the... I don't see where it is. The Evercade, oh, there it is. By my books. The Evercade EXP uses a Game Boy Advance cartridge pinout, but it uses SD card. Basically, it's just a SD card. And so, so I made a SD card adapter, and you can plug in all the Evercade EXP carts. I doubt that Game Boy Advance actually works that way, so don't try that at home for Game Boy Advance. But it is, yeah, it was kind of a fun thing. All right, so then the other grick stuff is should be easier. We should just be able to replace grick underscore with grick dot. It is a good way though. So all of the Evercade stuff, like if you need ROMs, all the ROMs are just right there on the cart. Pretty easy to read. And so like on a DSi or a DS, there's probably firmware for dumping the ROM there as well. If you have one around, it might be... I always try to find the cheapest way to do this. gpads is going to be an array, gpads1, followed by dot pressed. Oh, so this is already there. Interesting. So I was wondering how the... on soten.dev, they go through and they show you how to play as Richter. And so the code for doing that is already here. It's just behind this demo timer. And so this line is taking what is input on the second controller and putting it into Richter's like command entry. And so my guess is that the GameShark code just negates this condition so that it always goes to this this logic here. Crazy. It's fun seeing things like that. Okay, the Rick underscore, that also is going to be that one I want to match case. That's also going to be Rick dot. That's going into the entity table. And that broke something. Oh, I can't have those as declarations. gentity64. That's actually Richter. So I think the next thing is to start looking at some of the control structures. I'm going to look at the go-tos and the blocks. This is part of this particular block is part of the for loop that is going to be constructed. Maybe I'll try to do that. Varus2 is typically I, and that's what it looks like here as well. Looks like there's an additional Varus4 that we probably need to be tracking as well. Which looks like it might be a collider pointer. But it might be something before the GVRIC entity. So it's unknown 4C minus 6C. This would not... 4C would not be only 6C away, so we'll have to go do that math as well and see where this is. And this is the offset in bytes, not a... it's not multiplied by the size of whatever 4C is. So yeah, let's get our loop going. And I'm going to try to carefully replace Varus2. Often we'll have, in this case we don't. Sometimes we have Varus2 underscore 2 when M2C thinks it's being used for something different. But in this case, that's not what we have, so that's pretty easy. So for I equals 0, while I is less than 16. Why 16? Because the while down here is x10, which is 16. Get rid of our increment down there. And then var s4, this should be a 16-bit pointer. Yes. So I'm going to do a plus plus there, and that lets us get rid of all the go-tos, because once we fall down through the loop, and all these plus twos as well, And once we fall through, that will happen automatically. There might be an exit out of the loop up there that I just destroyed. We'll see in a little bit. Parse error before case on line 120. When you program in a lot of different languages, it's, well, at least for me, I tend to forget whether I need semicolons or not. Just get into the habit of one over the other. Yes, there are some differences here. It is possible that this var S4 is not being incremented every time. And that's why it's... actually, no, it is showing up here on 52. So there's something else going on. For some reason, that's not hoisted up yet. I do want to figure out what field that is, so we're going to go look at unknown 4C. And we want 6C ahead of it, which is going to be 72F00, which I think is the timers. Yeah, so this is going through the timers. So I think, so we have a macro to get that length. And what else? This might not be a pointer following this either. We might be incrementing it into it, and then GCC is doing the work to turn that into a pointer. But that's what we're doing. So let's do a few things to clean up here. So we're going to do len gric timers, which will give us the 16. Var S4, here's what I'm going to try to do, and we'll see if it works. Instead of using the pointer, I'm going to do gric timers I. And everywhere with that, we have var S4. It'll be a lot of places. We're going to do that. So this is decrementing that timer. And this is a pre-decrement with a not. And that lets us get rid of a whole bunch of stuff. And that bumped that up quite a bit, but then it brought it back down. But we do need to be doing this. It could be the pointer. That would be fine. Oops, I missed another one. We might be using a pointer still. We don't know that yet, but there's nothing else that uses it, so I don't think we need that. And GCC tells us we're probably right. There is a reference to player draw that's missing. I think we'll come back to that. Some of these look like they may or may not be out of order. Let's clean all this up because this is gross, and there's a bunch of temps everywhere. I usually go backwards through these. I find that to be a little easier. When there's RGB going backwards, it's usually an inline assignment like this, because then that puts them in order. And I like short lines, so I usually wrap them like that. And then I'm going to go through and just get rid of as many of these variables as I can. Is there anything... Are we... I think that this is going to be a division by 64? Is that right? 2 to the 6th. I think that's 64. So let's go to 92 and see what happens when we divide this by 64. Oh, the 103F is interesting. Oh, what is 103F? That's an interesting. Maybe it's divided by hex 1040. That makes sense. The shift by 6. Okay, so let's work out some of this other stuff. We're using the sign function from the SDK that takes an integer that's split with 12 bits for the fractional portion, 20 bits for the integer portion. For Konami, we need to shift that to the left by 4 bits to get it into the Konami fractional form. We're not doing that. We're shifting it to the right 6 bits. And what does that give us? That gives us 6 bits of fraction. Is there anything special about that? I don't think so. The 103F is throwing me off. That seems like a magic number, which would be related to some division or something else. So I'm going to try a few things and possibly fail at them. I think I have a utility to do this. So when we're adding values here, this temp S0, it's being added to this hex 200, and so we might think that that is what, 512? But it's not 512 because we have to remember that the bottom 12 bits is all fractional. So I have a couple utilities for converting those, and then we can get them into x2 a nice fractional form. So that's 1/8. And these are in radians, I believe. And so this would be 1/4. And then this is 3/8. All right, so then we're taking that and adding 1, which is should be float 1. So that is reasonable. And this is all going back to V0, so I think that these are going to be on the same line even. So R sign plus float 1. I don't think there's a reason to have a separate line there. This is when I would want the PSP version. Oh, I screwed that up. Yeah, I can't do that quite so boldly because we're assigning to different versions of each of these, and so I have to keep track of where this is going. So if I move that up, then I also have to move the right variable name up as well. What I want to eventually try to do is simplify this to the point where it starts to make sense to me. And it looks like this actually might... This is weird. Why 103F? That's a weird number. The shift... Did I get rid of the shift by 6? Is that what happened up there? I might have screwed up something else. And I wasn't watching the assembly, but this is getting worse. I'm going to revert most of that. All right, we'll leave it there. So we need to figure out... Oh, the +1 or plus float 1 maybe part of whatever operation is happening here. If we divide this by 1040, it's a weird value to divide by. So there's... Yeah, so there's something strange going on here with the way that this is. I'll come back to it in a bit. I'm not going to... My brain is not in the mode to do this at the moment. Usually when there's shifts and checks against 0, like this, in odd adds, usually that's because there's some division or mod happening, because we're converting between... the top of this is 4096. Because we're converting between... this, like, PlayStation formatted real number. I'm gonna try one thing real fast. There, that's close. Our shift right is wrong. So it's going to be something along these lines. The it looks like it is a power of 2 that it's being shifted by. We can try a bunch of them. Like 1 shifted by 6. How about that? That works. All right. The store byte here is coming from... It's left over from up here. So divided by 1 shifted by 6. Why is that number relevant? I don't know. That number has no meaning to me. I'm not sure. Why divided by 64? I don't know. So are these others going to be the same? Yeah, probably. So we'll do the same thing to those as well. And again, these are inline. This whole thing possibly is inline and not assigned to any variable. I will try that quickly as well. How many of these are there? Quite a few. Not familiar with the player draw structure, except that it looks like it is set up to draw a quad. Usually, like you'll have these 3D quads. A lot of the drawing in Soten is based on that. They're a primitive that the PlayStation can draw directly. And so you set up the colors at each of the corners of the quad, and then it'll do a gradient between all of those. That is one of the things that the PlayStation is famous for. This is somewhat interesting. We're not shifting. We're not using S0 here. We're using the game timer directly. That's different than the others. That may be a bug. I'm not sure what this is going to be for yet. So R61 code and below. It actually looks like no. That seems like an M2C error. Here we're shifting by... Oh, don't need to do it twice. We are missing a shift. However... Yeah, I don't know. These are being treated as different, but looks the same. I'm not sure what is causing that. I'm going to get rid of that because that shift isn't necessary, but we have an issue then where it looks like this should be one way and it's not. Player draw, we're ending up pulling the address. And so we talked a lot about caching yesterday and things getting, references getting cached early. And that happens with addresses like this. So we have an offset 8 for player draw. But it looks like an earlier address is being cached than I want. I actually don't see where that's happening. So S1, I'm gonna find out where the S1 register is being set. Okay, it's being set up here. We're doing player draw 158. So there must be something down below where player draw is also being used and we're not pulling the right, however the code is set up, it's currently not pulling the right offset to cache. That can be done for several different reasons. It might be that we're, since everything is going to player draw 8, that is pulled out into a variable separately. Not quite sure yet. Screen check. Thank you. Sorry about the screen. I talked a lot about this division, which I probably didn't end up showing, but that's what happened. Oh, that happens sometimes. All right, what to do next? I'm going to keep going down, fix some obvious things, and then circle back. When we see palettes like this, the 8 indicates the 8 is the top bit. It's a flag. We use the pal OVL macro to say that the palette is coming from the overlay as opposed to coming from DRA. Usually I would invert this mask. I don't know what the fields are yet, but this should work out to be the same thing. We can double check that on 109. No, not quite the same thing. This should be 10. And so if we had, if we knew what those flags were, we could just tilde those flags and get the right thing. Going down 119, I like using decrement and increment operators when possible. So here we're masking out the buttons that were held to determine which ones are being pressed. A few of the same steps that we've seen before. 70, I think, is one of the dead steps. The first thing I see that's different is here at .111. So when we see stack pointer named variables, they can legitimately be variables that ended up on the stack, but often they are structs or arrays that have to be allocated to the stack because they won't fit in registers. And there's nothing that tells me one way or the other. So I'm gonna proceed thinking that this is just a normal variable. This var 6, I'm gonna call that step. And var 5, step S. And var 5, that'll be step. They look like they're probably legitimately variables. My guess is that this is the ordering here could be a couple different ways. It's going to generate the same code. What I'm trying to figure out is what pattern here is going to load this hex 11, 17 earlier. Right now it's in the branch delay slot. So if you're not familiar with MIPS, a bunch of other RISC processors do this as well. The instruction immediately after a branch instruction gets executed before the branch takes place. So we have this jump and link, which is like a function call. And so its argument goes into the A0 register, and it looks like that's happening after the function is called, but in the way that the implementation of MIPS is that this LI, load immediate instruction, gets executed before you start executing the code at this jump location. It's kind of an odd decision. I'm not sure why that. Well, not terribly important why it works that way. It just does work that way. So there are various things that will get this to move up. And in this case, it's saying we're storing the value of V0, which is this, I think this assignment. Yes? Yeah. We want to store that in that branch delay slot. So I don't know what yet is going to cause that to happen, but we'll figure that out in a little bit. This is an odd OR. I wouldn't expect a human to write code like this, so I'm guessing it's a GCC optimization. I think that it's more likely something like this. I don't think most people would think of hey, I can be wrong. I don't think most people would think of ORing two timers together, but possibly. That's possibly some of the difference between West and East programming. This var v0 s5, that's just going to be an assignment directly to the stack pointer. All right, 163, this is where we start getting into differences. So here's our step. This is kind of the main branch point. I'm going to, one more thing before I get here, I'm going to get rid of this go-to. There's very few go-tos in this code. Like most code, there's not a lot of go-tos. When that happens, usually it's just duplicated code that the compiler has deemed that can be the same. The fact that the step and step S are pulled out into variables is a little strange. I'm somewhat inclined to think that that is not the case. It's also possible that they're not actually even parameters to these functions. But these do look like all of the steps that we've seen before. So there's some differences here. Let's see. I'm going to try moving those back to Rick.step unless that got changed somewhere in here. I don't see a reason to put them in variables. I know that that's how the code ended up being written, but no, it didn't. That made it much worse. So I think I'm going to have to... there must be something else down here further that is going to end up collapsing these. Yeah, so actually these might... It might be the opposite, that these are all just step. We'll see if... because then that can be put into the A0 register very easily. And sometimes when you have repeated code like this, you don't see the match until you get most or all of them done. So that's looking better. A few more. It actually didn't improve anything though. So yeah, something else is pulling those in. And I'll have to take a look at that later. I'm actually out of time though for today. So we'll continue this tomorrow. This is Richter's main logic. It dispatches to each of the different things that Richter does, and we'll figure those out along the way. So if you're not familiar with this project, go to soten.z.dev. We're decompiling Castlevania Symphony of the Night and getting back to C code and getting to learn how the game works. Getting to learn about decompilation, C, MIPS, all that fun stuff. I'm here Monday through Thursday doing this for about an hour and a half, 2 hours, and I'll see you tomorrow. Adios.